The return statement in Java programming language is the same as the return statement in C programming language. So the syntax to return a value is this one, okay? The keyword return and then followed by the value to be returned. This could be not necessarily a value. This could also be a variable. It could be also an arithmetic expression, okay? Like for example, you would say return area, okay? Where area is a variable which has a value. So what will be returned to the caller is the value of the variable area. Or it could also be an arithmetic expression. You could say return 3.1416 times rad times rad. Okay, so this part here, okay, which is this one, is an arithmetic expression. So what the computer will do is to evaluate this arithmetic expression first. Once the value of this expression is obtained, then that value will be returned to the caller of the method. It is possible also that you have a return statement without returning any value. So what this return statement will do is simply to return to the caller of the method where the method is called. It will just return to that point and it does not return any value at all. It will simply go back to the caller of the method or where this method is called. So in here, we outline the steps on how to write a Java program. First, we are going to prepare a source code file, and then we declare a class like what we did in the lecture demo when we created the Hello World Java program. And then you give it the same name as the source file to the class name. So remember that the class name, like this one, sample, should be the same as the source file name. So the file name would also be sample. And the extension is .java because this is a source code. So just like in our lecture demo, the Java class name is hello and the file name when we save it is hello.java. Third is we write methods between the opening and the closing curly braces. So between the opening and the close curly braces, which defines, okay, the scope of the Java class. Between this, or meaning inside this, you're going to define, you're going to write methods. Okay, like in this case, for this Java class sample, we have one method, which is this, as defined by the open curly and the close curly. Okay, this is the first method. And the second method is this one, which is the main method. And recall that the main method is the execution entry point. Okay, when you run this program, this Java class, the execution entry point is the main method. This is where execution starts. All the rest of the methods are just called from this entry point, the main method. The fourth is write the method implementation between the two curly braces that define the scope of the method. So say for example, this method, the scope of that is between this one and that. So you're going to write in here the implementation of the method. Okay, we call this part here as the method implementation. Next is the program starts with the main method. So just as I've said a while ago, that the execution entry point is the main method. Okay, so again, the program starts its execution with the main method. And lastly, declare fields at the same level with the methods, or fields are declared outside the method, just like this one. This field is declared outside the methods. If you declare a variable in here, say inside main method, say for example, inside main method, you're going to declare a variable here. Say the variable is integer type and the variable name is x. X here is called a local variable. Local variable declared inside the main method. If we, in this method, we also declare another variable, say for example, the data type is float and say the variable name is y. So y is a variable of data type float and y is also a local variable inside this method. So variable x here is a local variable of method main, while y here is a local variable of method. And total count is called a class field. Okay. And although it looks like a variable declaration, it's actually a variable declared inside the class, but the specific name for this one, this variable that is declared inside the Java class but outside the methods, we call that a field. When you declare that inside a method, okay, say for example, you erase that one, and instead we declare it here. We say int total count. So total count is declared not in here, but inside the main method. If that is the case, the total count is declared inside the main method, then we don't call total count a field. We call total count a local variable of the method main. Okay, so again, variables like this one, total count, is called a field if it is declared inside a Java class but outside the methods. Okay, so this one is outside the method, therefore we call this a field. While if it is declared inside, if we have here int total count, then this total count in here is a local variable of main method. Okay, it's a local variable. We have in here the syntax to declare a Java class, and as we have already discussed earlier, we use this access modifier public to make this Java class accessible to the whole project, and then follows the keyword class, which tells that this unit that we are creating is a Java class. And then what follows is a class name. Like what we did in our demo, we say public class hello, and then open curly to mark the beginning of the Java class, and the close curly to mark the end of the scope of the Java class. And inside this open and close curly, we could declare fields and methods. Okay, so how many fields? 0 or more fields. How many methods? 0 or more methods. So as indicated here, you're going to write in here, inside the scope of the Java class, the fields and the methods. Now, how do you declare a method? Okay, so this is the syntax. The return value type, like when we say void, that's the return type, and then the method name maybe is compute, and then the arguments, like for example int are. Okay, so this method has only one formal parameter. Okay, we call this a formal parameter, or we could also call this a formal argument. And then after the argument is the open curly to mark the beginning of the scope of the method, and then the close curly to mark the end of the scope of the method. So what you have in here inside the scope of the method is the implementation of the method, which is the set of code or codes or statements, executable statements. And how do we declare a field? To declare a field, we simply indicate the data type. Okay, so this is the data type, and then the field name. Okay, so say for example, the data type is integer, and then the field name is the one a while ago, total count. Okay, and then semicolon. Or you could say float size. Okay, size is a floating point data type, and it is a field because these two, total count and size, are declared inside the class but outside the methods. A statement in Java is also terminated by a semicolon, just like in C programming language. So we have, maybe if this is the main method, we have here the open curly and the close curly. Okay, this is the scope of the method. Then we have here one statement. Say you say system out dot println. Then you say something here. You terminate that with a semicolon. Then say we have another statement here. Say this is y gets x plus a, an assignment statement. This is also terminated by a semicolon. So every executable statement in the code is terminated by a semicolon. Now, as you have noticed, many of the syntax and semantic of C programming language statements or programming constructs are the same in Java programming language. The reason for that is the parent programming language of Java is C programming language, or Java programming language is written in C programming language. That is why most of the programming statements, syntax and semantics of the C programming language is the same as in Java. The term block in C programming language and in Java programming language, they have the same meaning. Okay, so a block refers to the scope between the open curly and the close curly. And what's inside this open and close curly are the executable statements. Okay, and this set of executable statements is what we call the code. It consists of processes. Processes referring to the code or the executable statements. And just like C programming language, Java is case sensitive. So when you write this one this way, println, where P is uppercase, okay, Java will not be able to understand that. Okay, that would be unknown because the built-in println method is small letter, all small letters. So P uppercase is not the same as small p, and small a is not the same. This character lowercase a is not the same as the character uppercase a. Okay, so it is case sensitive. To declare a variable in Java programming language, it is still the same as in C programming language. Although in Java, you could specify an access modifier. In C programming language, you could actually also specify an access modifier, but that is not commonly used. In Java programming, it is widely used to include an access modifier when declaring a variable or a field or a method or a Java class. So what is the syntax to declare a variable in Java programming language? As I mentioned, it is the same as in C programming language, the type and then the variable name, okay? Or the data type and the list of variables, okay? Just like when you say int x, or you would say float r, comma, area. So this is a variable list separated, two variables in the list separated by a comma. It is equivalent to declaring them separately like this. R is float and area is also float. Instead of declaring it this way, two separate lines for the two variables, we write them as one declaration, listing the two variables this way, separating them with a comma. So this is a better way of declaring the variables because it saves some space rather than declaring it this way, requiring you to have these two in separate lines. For the primitive types of Java language, it has 8. In C programming language, you have 5, right? Including void. In C, recall the 5 atomic data types are, what are these 5? You have character, integer, and then we have float, and then double, and the fifth one is void, which is valueless. In Java, we have 8 primitive types, and these 8 primitive types are grouped into 3. The first group, called integral, are byte, short, int, long, and char or character. And for the second group it's called floating point. In this second group, we have float and double, just like in C programming language. For the third group, it's Boolean, and the Boolean data type belongs in here. So for the first group, we have 1, 2, 3, 4, 5. For the second group, we have 2, 5, 6, 7. And for the third group, we have only 1, so 8. That would be 8. For the variable naming convention, you can use characters for the variable name. And for characters, you can use the alphanumeric characters, referring to the uppercase letters of the alphabet, the lowercase letters of the alphabet, and the 10 numeric digits from 0 up to 9. So we call this the alphanumeric characters, letters and digits. The letters can be in uppercase or lowercase. But the first character cannot be a digit, just like in C programming language. So, say you declare an integer variable, you can say xy3, okay? That is the variable name, xy3. But it cannot be 3xy, okay? This is not a valid variable name, but this one, the one that starts with a letter, is a valid variable name. It may also contain an underscore and the dollar sign and the multi-byte characters, including Japanese characters if you have installed the Japanese characters, and any other multi-byte characters, not just Japanese characters. The reserved words which are listed in here, this cannot be used as a variable name because these are reserved words, or these are words that are associated with the programming constructs or statements or keywords in the Java programming language, and therefore you cannot use them as variable names or function names or field names. We have here examples of variable declarations. First, if the data type is byte, so we write it this way, and say we have three variables, A, B, C, which are of type byte, then we could put them in one declaration line. And this part here, we call this the variable list. And since it is a list of variables, these three variables are separated by a comma. Now, the second line, we have here variable sum declared of type short. The third line, we have here two variables I and j of data type integer. Total number is type long. Answer is type float. So this is a real number as well as data, which is double type. This is also a real number of wider range. Result is a variable of type Boolean. So since it is type Boolean, the value that you can assign to variable result could either be true or false. Key input is type character. So you can assign to this variable any character literal such as M. Okay, take note that a character literal, okay, another word for constant is literal, or you could refer to that as a character constant instead of a character literal. Now, recall that whenever you have a character literal or constant, you enclose the symbol or the character with single quotes. If instead of single quotes, you use double quotes, like this one, this is no longer a character literal. Instead, this is called a string literal. Okay, so remember the difference between character literal and string literal. Okay, character literal is enclosed with single quotes, while string literal is enclosed with double quotes. Now in here, we have two variables, A and B. A is type byte and B is type short. Now this declaration is marked as wrong. Although the compiler would still accept this, you will not be prompted with a syntax error for this line, but this is not appropriate. Okay, so it is inappropriate. That is why it is marked with X, meaning wrong. Because when two variables are of different data types, they must be declared on separate lines, like what we have here in the second and in the third line. So instead of us declaring these two variables of different types in just one line, we declare them in two lines. On the first line, we declare A of type byte, and on the next line, we declare B of type short. Okay, we separate these two variables into different lines because they have different data types. So by convention, in programming, you have to declare several variables in one variable declaration line if and only if these variables are of the same data type. Okay, so just like what we have here in the next example, we have variables A, B, and C. Why do we declare them in just one variable declaration line? Because these three variables are of the same byte type. So instead of us declaring them in three separate lines, like when you say byte A, another line byte B, and then the third line is byte C. So instead of us declaring it this way, three lines, we could instead declare these three variables in just one line. And in that case, we save space, right? Instead of occupying three lines in the editor, these three variables occupies only one line. And that is a better idea because it saves space and it makes your code shorter. In the third example, we have here a declaration of a variable of type integer. And take note that aside from declaring a variable, we could also set initial value to it. So in this case, 10 is the initial value of I. Again, 10 is an initial value. It is not a fixed value. You can change the value of variable at any point in the program. Since this is a variable, its value can be changed. So upon declaration of this variable I, you could choose to set an initial value to it, or you could just declare it without setting initial value. Okay, so you could declare it this way: int I, declaring variable I without any value, or you could declare it and at the same time set initial value to I, which you could later at any point in your program change it to something else.